Hello, good afternoon, everyone. Welcome by our Smitio online coffee. This topic is about Jetpack Compose and how it can speed up Android development. We have Mykhailo Kostyria from Dactyl group as Android developer here, who will be giving us the presentation. Hello, Mike.
Hello.
At Smitio, we do more of those events about knowledge sharing in different topics from IT. So feel free to join our Smitio community and get invitations for more events like that in future. If you have any questions, feel free to write it as it comes into chat, but Mike will go through the questions at the end of the session. So I think that's it. Enough for the logistic. And Mike, it's all yours, Jetpack Compose.
Okay, thank you so much for the introduction. So I'm a software engineer at Dactyl Group, and this is a presentation on Jetpack Compose for both beginner and intermediate users. I'm going to be showing some of the not only practical examples, but also some of the best practices you would likely want to follow. And some of the advices I would give to people that are newer to this topic, because Jetpack Compose is much different from XML, and you will likely need to spend some time and effort to be able to get into this. Now, the question that would obviously arise first is, why would you even care about this? And there are two main reasons. Well, the first of all, basically, it's your time first, and Jetpack Compose will actually give you an opportunity to achieve your results much, much faster than using a traditional XML and separate Kotlin file approach. And the second reason being is it's actually already a big thing, and the people are basically either those that have already been able to work with it, or people that are just planning to use it, but didn't have an opportunity yet because they have some more legacy project that is obviously not going to integrate Jetpack Compose, but they are still thinking about using it in the next project. And this is a tendency I can clearly see taking place in years to come. And in a couple of years, I feel like there would be no reason for XML to even be considered like an alternative. So it's more like staying competitive and relevant to the market, as well as being on top of the newest technologies. So what is actually Jetpack Compose? So Jetpack Compose is a modern toolkit you use for building UIs, obviously, as I said it before. And in fact, it's so modern that it's still in beta. It's still in beta, but it's already really performant. It's really easy to use once you know how to do so. And it provides an immense amount of features and integrations. So usually when you see that something is in beta, you would assume that there are little to no resources on the web, and there are little to no integrations with other stuff like navigation component, for example, which is clearly very important and useful. But thankfully, with Jetpack Compose, you have all of that stuff already. And the only problem you can see arriving is, obviously, the more time passes, the more resources and questions will be asked on forums like Stack Overflow and stuff like that. So it will be easier for you to fix your problems. Obviously, as this is new, there are not as much stuff covered as for XMLs, for instance, but you can clearly see that time is going for Jetpack Compose, and the longer it takes, the more stuff will be covered, and the easier it will be, the more stuff will be fixed, and you'll have no issues. So, as I am stating, as the title of this presentation states, that Compose is the future of UI development. Obviously, there are going to be a lot of it will be compared with XML a lot, obviously, because this is what was used or is currently used. And the one thing you can see on the right side of the screen is basically just two very, very simple examples that are simply in order to compare the syntax. You would likely think that these are taken to show off that, oh, wait, take a look at that. It's so much faster and easier to do with Jetpack Compose. No, obviously not, because this is not a realistic example. It's merely to show off the way you define certain UI elements, and you can see that it differs fundamentally. There's nothing really in common between the definition on the top and on the bottom. It's a Kotlin code on top, XML tags on the bottom, and they have nothing in common. And while that might sound exciting and actually be one of the pro things towards that, this can in fact be something revolutionary because it actually differs and not some XML2, which would likely be interchangeable or the same, because Jetpack Compose is something that you actually use instead of XML entirely. In reality, it also means that it is harder to get into. So you indeed can achieve some insane results. You can indeed work much faster and get much better UIs, but you will have to spend some time learning it because it changes the fundamentals completely. There is pretty much nothing in common between Jetpack Compose approach and XML one. So it's not only the fact that you don't need to know XML tags, you don't need to know the knowledge of XML attributes, layouts, and stuff like that. It also changes the fundamentals, and I will be covering this a little later on in the presentation. But I mean, you can already see that it's not something that you can just pick up in one single day. I would probably say that it's more like learning RxJava the first time when you've never encountered anything reactive in your life, and then you just waste a week trying to understand what's even going on. And it's quite the same with Jetpack Compose. But once you do get it, you basically don't want to use anything else. So first, we'll cover like some abstract concepts. There are actually 4. I would also consider composable function itself, the one defined here in the message card. It's composable function. And besides, there are layouts, theming, and state and data. Now, the layouts is actually one of the easier ones, as well as theming, actually. So in XML, I don't know about you, but most of the people I've seen were probably just using constraint layout 80% of the time, or even more. And they would not have to bother about relative layouts. Linear is actually one of the more useful as well, obviously. But they were basically just a bunch of different layouts that you were either forced to use in order to show snack bars or toasts, or just some layouts that existed but you forgot about them. There are much more useful layouts in Compose. There are 3 basic ones and a couple of the additional ones that you can use. And what's interesting is that constraint layout is not even a part of the basic ones. So as I will show a little later, you will likely not even have to use constraint layout at all. I don't know what to say at all, no. But it will be used so rarely that you will actually have to check Google each time to remind yourself syntaxes, because you will forget it by that point. So for the layouts, there are 3 main ones. It's a box layout, it's a column and row layout, and I will cover all of those a little later. But in short, it's basically just a frame layout and a linear layout with vertical or horizontal orientation. That's it. And for the additional, there is grid layout, which says for itself, and constraint layout. There are probably some other ones that are custom and are added a little later, or can be added with a specific dependency, but I will not be covering those. For theming, the second key concept, thankfully, Jetpack Compose introduces you with a bunch of ready-to-use instruments to begin with, a bunch of ready-to-use materials, theme elements with day-night theme and stuff like that. And it's very easy to customize, very easy to use. And thankfully, it doesn't take a lot of time to set up. And finally, the state and data. This is the most advanced concept of this all, and I will be covering it towards the second half of the presentation. Basically, in Jetpack Compose, you handle the data changes way differently than you do in a regular XML layout, because here, instead of telling UI which steps it has to do in order to update the data on the screen, here you kind of react to the changes automatically, and it's quite hard to understand at the beginning, but I will try my best to give some thorough explanation on what's going on with some examples, so it will probably be easier to understand. So before we dive into some practical demo project I've set up, let's just take a look at some of the syntaxes we are going to be using, just so that we are all on the same page here. Basically, what's a composable function? It's pretty much a regular function in Kotlin code, the same function you were always writing, except it basically just returns a UI element to your parent composable, and it is displayed on the screen. That's pretty much it. So the stuff you see, for example, in the top right, you can see a message card. Well, if you take a look at the column element, you might be, if you're new to the Compose, you might be thinking like this is some magic keyword or something, but in reality, it's basically just a regular function that takes contents as a lambda. So these two text elements are basically just an argument to this function, which is then shown on the screen. So it's really nothing magical, nothing special. It's actually plain simple once you understand that this is something you have been working on this entire time. It's the only thing you have to be aware of is that the composable invocations can only happen inside the composable function, which is quite similar to coroutines if you think about it, because you could only call suspended functions, for example, from the coroutine context, right? You could not call them from like regular function as a regular function. On the bottom left, you see probably the most important thing you're going to be using with composable functions, which is modifier. Modifier is basically your way of defining sizes, paddings, shadows, shapes, backgrounds, everything. This thing has an insane amount of utility. It has a lot of potential to be used. And for the custom composables you're going to be defining, and you will be defining a lot of those, you are going to be using modifier for each and every one of those. First of all, to make them reusable. Secondly, because you will not be able to do much without modifiers except for displaying hello world, pretty much. So this is a very useful thing. It has a lot of utility. I will not be covering all of the utility it can do, but you can already see on this basic example that it can clip the image in a circle shape in just one line of code. If you were to compare it with old XML approach, this would have likely taken much more lines, obviously. And on the bottom right, you can see your first lazy composable here. Now I could name 3, which are lazy column, lazy row, and lazy grid. There will probably be some other ones, and maybe you could add some dependencies for some other ones, but these are the three I am aware of. And this is one of the really powerful features when it comes to Compose, because lazy column is essentially your recycler view. So if a column is a linear layout with vertical orientation, lazy column is basically your recycler view that does not need any adapters, anything like that. All of the work is delegated to framework, so you don't have to test whether it's probably recycled and stuff like that. And it also provides you with a bunch of very nice and pleasing animations right off the box. So sadly, I did not I was not able to add some bits as a part of the presentation, but if you were to try it yourself, you would see that your views stretch in a very natural way once you reach the end of the list, and this is not something you were provided out of the box as XML. And it basically is just a way to create more user-friendly interfaces, which are more dynamic and more responsive in much less lines of code. So this is actually all the code that it takes to make a lazy list like this. So it's basically just 5 lines. You don't need no adapters. You don't need to override any adapters. You don't need to provide any view holders. This is everything it takes, and it works really good. I haven't encountered an issue in terms of performance. Not a single time I've used lazy column, especially if you know a couple tricks, which I will likely cover a little later, depending on how we will be doing in terms of time. So I've set up a nice little project, so it's not just about me providing some abstract examples. This is, as I was just talking about lazy column, this is a very simple project that will be simply focusing on some of the tricks you can use and how to set them up. So this is a lazy column, obviously. And on the right side, on the screenshot, you can see the example of providing your own composable, which is something you should be doing immediately. Anytime you encounter some design choice in your Figma, for example, or whatever software you use, that you can see is going to be repeated, obviously, you should not waste your time and immediately define it as a custom composable. As you can see, the syntaxes can be like a little tricky to begin with if you look at the content part of the function definition. It's not something you were likely using all the time, but basically it's really simple. And in this case, it basically just provides you with a universal card you can use for this project without having to define its attributes every single time. So it's pretty much like a custom view in XML, but very easily implemented and very easily used. Here are just a couple code snippets I decided to add to show some of the useful stuff you can do with Modifier. So I like the example on the top, which is basically Android image is obviously a custom composable I've defined myself that takes modifier as a parameter. And this is the way you get this nice little picture, which covers the entire width, and it has the height without any of the hard coding, which stays consistent across all of the screens. You do this in basically 2 lines of code by defining aspect ratio. So every time you see the Android image in this presentation, it's all the same, same image, but used with a different modifiers, so as to kind of show off what it actually can do. And on the bottom, there's not such an interesting example. Is basically, again, a custom composable which defines a text without reusing without copying the attributes, but in reality you would likely use styling. So this is more for the demonstrational purposes only. One other thing that is really handy is the fact that you have the clickable interactions right out of the box. So if you were to define a button that is clickable in an old way, you would likely have to provide a selector with a bunch of colors, which is button clicked, button idle, or whatever it was. Well, here it's actually provided to you out of the box, and you will have really nice ripples on each of your interactions. If you are using it with a card, you will actually get changes in the elevations. So if you have a shadow and you click on this card, you will actually see that the shadow gets smaller, and it provides an insanely dynamic UI. And on the bottom, well, obviously this would be encapsulated in a different function in a real project, but for the sake of the screenshot, I decided to implement it here. This is basically the way you combine it in a single picture, 2 images inside of a frame layout. Quite handy with clickable functionality, I would say, especially considering that it's pretty much the same all the time. You always want the same how's it called, behavior for your button, regardless of the project. It's not like you want to click on the button and see like red ripples or something like that. It's always the same gray ripple, and the fact that you can have it without any code written by your site, I think it's pretty handy, and it saves you your valuable time. Now, the next couple examples will be more specific. Mainly, I will be showing the usage of SnackBar in this one. So this is something that can differ from one version of a library you're using to another one. I'm currently using Material 3, and it's defined like this. It is probably going to be used a little differently depending on which version you use. But already you can see that aside from all of the other useful stuff, you also get native support for coroutines, which can be used in a very intuitive way here, very readable. And you will be likely noticing the remember keyword on the upper screenshot. So I will be covering the remember function a little later, but you will, for now, you should just consider it as a computation that is only done on the first composition. So whenever this function gets called again, it is going to be using the same value that it has used before. And as this is the last screenshot we're displaying a toast, this screenshot is going to be about setting up your floating action button. So again, it's going to be differ depending on the library you use. But here, you can see a nice easy setup for the floating action button. And as I said, I will be coming back to remember. This is the moment. So you can see on the upper screen, one of the most confusing, but also one of the most powerful things you're going to be using is remember mutable state of. Now let's break it into the underlying elements. So remember, as I said, is simply going to be used in order to not do any computations again on recompositions. So it's not like it has to contain mutable state of inside of it. Remember is basically just like, you can think of it like a static variable in C++ inside of a function, something like that. It's pretty much, it behaves pretty similarly. Mutable state of, on the other hand, is one of the more confusing elements, but the one you're going to be using all of the time. You just have to understand how it works. You have to. You can think of it kind of like live data, except it isn't, and there is no live data used in Jetpack Compose whatsoever. But it can be seen in a similar way. Each time the value of the mutable state is updated, the functions, the composable functions that read its value are going to get recompositioned. So you can think of them as observables to this live data. Again, except they aren't. And depending on how you experiment with it and how you define these things and how you structure your mutable states, you can, first of all, get really great results with little to no effort. Second of all, you're actually going to improve the performance of your application. Because, as this is my favorite topic of advanced stuff in Jetpack Compose, if recomposition is triggered each time as a function that reads some mutable state, each time this mutable state gets updated. So obviously it might sound exciting at first, but in reality, it also means that now you have to structure your UI code in such a way that you minimize the amount of recompositions needed, and you minimize the amount of computations, amount of extra computations you do by leveraging the remember function. So I'm not sure if you've encountered the pattern of using stuff like view state, which is basically, instead of defining separate fields inside of your view model, you would have one single data class called something view state, which encapsulates all of the fields at the same time, and you would just pass it to the child fragment or whatever, and it takes care of it. Now, I personally considered it an anti-pattern to begin with, but here with Compose, it's actually even more harmful because, as I said, there is no live data, and all of the recompositions happen on the changes of mutable state. So, should you be changing your view state like this, defining it as a mutable state, you will actually trigger recompositions across all of the child composables. The framework is designed in such a way that recompositions are only done for those composables that actually need it. Otherwise, should you be updating the entire screen each time some little stuff changes, you would have had some performance issues. And they've done some effort to for this to not be the case. And imagine after all of that, you're just using mutable state for the all of the data for your view, so that your entire view is updated. So obviously, it's not my personal preference. It's just not recommended in general to use this for Jetpack Compose. We'll cover some of the other topics from here, starting now. We will, first of all, cover the advanced layouts. So as I said before, you will likely not be using constraint layouts pretty much ever. And here is a screen that describes that in a very intuitive fashion. So by looking on the left screen, you would probably think that it's a bunch of constraints bundled together, and this is some complex view. Well, in reality, it's just good handling of the basic layouts you're provided with. And on the right screen, you can see pretty much each of the elements used in order to achieve this, with different background color for each element. So what you can see here is actually just a parent row, which is a horizontal linear layout. And a couple child vertical linear layouts, a couple columns, and that's pretty much it. So the things that will help you to achieve this and do some really flexible layouts is a thing called spacer. Now, spacer is pretty much just like some empty element. You could consider it as something you can use to achieve margin or padding, but in reality, it has some of the more hidden potential that is not intuitive to begin with, but once you know it, you're pretty much good to go. So as you can see on the top screen, you can define the weight for the spacer. And what it means is it basically fills the entire blank space between elements, allowing you for the creation of whatever complex view you need without any overheads in computation of sizes of each element and stuff like that. So this is another thing I would recommend encapsulating as an extension function at the very beginning of your project, maybe just reusing it from time to time, from project to project, because it's actually very useful and you will likely be using it a lot. And on the bottom, you can basically just see my personal preference of defining paddings, because obviously you're going to be using a lot of the same combinations of attributes for your modifier, and instead of just copy pasting them from time to time, you can encapsulate it in an extension function, and obviously writing stuff like max width padding on the very bottom is much more compact than writing this entire fill max width and padding every time. So each time you feel that you can make this process a little shorter, instead of leaving a to-do, like encapsulate this in an extension function or something like that. You would be way better off to just simply do it immediately, and all of your work will be much easier from that point. Now, as I said about the custom, not custom, but out-of-the-box support for the day-night theme, this was done without any of the code written by my side. I basically just switched the color theme on my phone to dark, and application already has all of the necessary colors from material library available. No work needed to be done by me, which is always a good thing. And as for navigation, so for those using navigation components, you were basically you're probably aware of how it works, that you would have to define some XML tree. You would have to define some attributes in your XML file that defines the navigational tree. Well, you do this differently in Compose, as you don't have XML. You are likely going to be defining your entire navigational tree either in some separate file and then embedding it as an app host into your main activity, for example, or just basically defining it straight in the activity. So as you are no longer calling any of the child fragments with specific set of attributes, you don't even have fragments at this point. So it's getting hard to understand how to define these how to define this navigational tree. So you are doing it in a pretty similar fashion to what you would be doing in deep links using navigational component. And this here on the top screenshot is basically just a proposal. The way I use it, basically just having a base item and then joining it to a list of arguments separated with a slash. This is the way I do this. You can obviously do anything else. Like, for example, you can be replacing the route you need to take with each of the arguments you need. This is basically just the way I do it. But on the bottom, you can see how you would be defining this in your navigational host. So as you can see, this is not something that is very compact, because as your navigational tree grows, obviously this code is going to be more and more uglier. But with some separation and some encapsulation of different elements from here, I'm pretty sure you can achieve some great result. After all, it's all used on top of the Kotlin, so it's up to you on how to make it shorter, easier, and more reusable. And one of those topics that are also very interesting and not intuitive, and there are little to no resources on the web about it, is actually how you would pass your data to this screen you're trying to show, right? So as I said, you no longer have fragments. You no longer can pass any arguments inside of the bundle to call the fragments. Now, how do you do this? How do you do it? So there is some pretty magical thing called set state handle for your view model. I mean, I call it magical, but really it isn't. It's just basically something you would be normally achieving with your dynamic injections. Instead of your fragment being in charge of what data is passed to it, you get it directly in the view model, which I personally consider it as a great step forward. Because if you think about it, why would your fragment even need to know which data it was called with? It's depending on how purist you want to be about this. It's basically just breaking the single responsibility principle, because your fragment should be responsible for how to show the data, how to breach the data from your view model to your XML layouts. Why would it care about how it was called? And here you no longer have this problem. You're basically just exposing this data from the arguments the same way you would be exposing any regular data as a mutable state of. And as you can see, you can actually use it immediately and not when some operations are finished and stuff like that. So on the bottom screen, you can see that on the 32nd line, it is used immediately. Which is also a great thing, because this can be handled as like a constructor injection instead of a field injection. So you no longer have, not no longer, but you don't have any of the delays associated with this item's initialization. So this all might have sounded quite interesting and exciting. So let's actually think about how you would be using it if you were having a project that you are already working with that is obviously not using Compose. It's in using after all. So you were likely using XMLs for 3 years on this project straight. Now, if you think about it, well, first of all, it depends on the architecture you're using, because if it's not something like clean architecture that has your view module completely separated from the domain and data module, and you have them all interchanged together, obviously you're going to be having a really hard time. If you do have some normal separation, and you're actually willing to integrate Compose into your already existing database, you would actually still have quite a lot of work to do, because first of all, you're going to be having to change your entire view module pretty much. Secondly, you're likely using live data right now, but as I said, you don't use that in Compose. So you will likely need to introduce some adapters to be able to go from live data to mutable states, because you are not likely going to be able to work on this for 1 month straight. You will likely have some other tasks you need to do with the project, like some bug fixes, for example. And if you just start introducing mutable states all at once without any adapters, or without doing it gradually, you are not going to deliver any bug fixes, first of all. And second of all, you are not going to be able to work on this project for anything other than Jetpack Compose migration, because it's just not going to work until you've finished the entire integration process, which, as I said, is quite complex. Thirdly, all of your XML views are pretty much going to be trashed, aside from the fact that there are a couple special XML elements that are supposedly going to help you. I have not used them, but they're supposedly Android View and Compose View XML elements that are allowing you to embed your Compose code right in your XML. So it is likely going to help with gradual introduction of Compose into your code base. Now, I have not tested it, but even so, you can already tell it's not going to be an easy process. And personally, I would rather just save Compose for the next project and leave the existing one as a legacy code. However, if you're willing, and if you're not, if your project is not 10 years old, and you can feel that with the continuous support for a month, you can make your code base better, and you will be introducing some features, improvements later on, some new modules, new functionality, then you're good to go. You will likely be able to handle this properly. Now, as for the best practices, I will not be covering a lot of examples here in terms of code, but as for the theory, you can already tell that stuff like recomposition is very crucial here. That depending of the way you structure your composables, you are going to either have an insanely performant UI, or a UI that might get some freezes depending on how you've handled the mutable states and all of the computations and stuff like that. There are actually some almost not known about things like, for example, derived state of. So this is basically just like a live data combination. Instead of using two mutable states that are both used to achieve the same result, you can use derived state of to be able to combine them into one and do some computation. For example, this is a thing that you will not likely be seeing immediately on any of your Google Code Labs, and I highly encourage you to do those, because this is something you can only get with practice. But you will not see this stuff there. And this is just something you will have to be Googling for yourself and see how it impacts your project and how it can be used in your flow. And if you will figure it out, then you will get some performance boosts. Now, as I've already stated, that you don't want to use your view state, which encapsulates all of the field, as a separate mutable state. What I did not mention is you also want to make your composables as modularized as possible. You want to keep them at the lowest minimum level you can. So instead of having, for example, one container composables, one container composable, and then 2 little composable children that are doing their own stuff, you actually want this tree to be much, much larger, so that you can first of all call each of the composable, each of the child composable with only the bare minimum amount of data needed. So if you are using only one mutable state, for instance, to be able to render a text view, that's great. That's exactly what you need. Why would you need more than one? And this is what you should be striving for, to be able to minimize this. So as little changes as possible will trigger the recomposition. Not as little, but exactly the amount of changes needed will trigger the recomposition. So you don't have any side effects that some of the irrelevant data changes, but this view gets updated regardless. Why waste your CPU? Why waste your battery? And why waste your frames per second, right? First of all, it helps with that. And second of all, as you might have guessed, since Compose is written in Kotlin, not written Kotlin, it uses Kotlin to be able to, for you to be able to declare what the UI should be. Obviously, it's going to be easily testable. Obviously, it is much easier to test Kotlin code than some XML trees. And there is actually one feature I did not mention, which is the preview. I did not mention it because I personally haven't used it much, but essentially what it means is that you can, once you define your composable, you can preview the way it is going to look in your Android Studio without building your project, without running it on your phone or emulator. It sounds useful, obviously, but I personally did not have to use it much because I don't have any issues with builds. They're all very fast on my device. But for the projects that are much larger and you're doing one specific thing that requires a lot of actions in order to get to, obviously this is going to be very helpful. This is for the design. However, as for the testing, obviously you can do the same way. Now, if enough interest is raised based on this presentation, probably I could do some another one with testing as a main purpose. It's just it's way too much to talk about because obviously testing is always like a very important large concept that differs from your regular development, but it is strictly connected. So if any interest sparks, maybe we could do that in the future. And well, as you can see on the slides, there are obviously some other stuff like using immutable data or using named parameters, but I consider those to be pretty obvious. And well, we all know that we should be striving for readable code. So I don't think that it's something that should be mentioned. After all, it's Jetpack Compose specific, while readable code is something you should be striving for all the time. What else do we have here? So, well, as to sum it up, now I think that even based on the examples I've provided, I'm pretty certain that there is no real way for debate whether you should use XML or Jetpack Compose to exist. I'm pretty sure XML's place is either in history or in a legacy project, and all of the future ones should be done with Jetpack Compose. There is no real need to be able to define a separate XML layout file with a bunch of view groups. There is really no pros, I could say, except for the fact that XML allows you for separation of concerns, so to speak. So you have XML that is only used to describe how exactly should the screen look, and you have your Kotlin fragment that is a bridge to pass data to it. So that's a nice little separation of concerns, because this way you can have one person responsible for doing an XML design, a different person responsible for bridging it, third person responsible for view model, stuff like that. Obviously, this is more relevant to larger teams, and if you are working in a smaller team, you're only going to have problems from this overhead. It's not like you're going to be saving your time by copy pasting a bunch of XML tags. You're just really gonna have to work with much less well, I don't say scalable interface, but it's just a headache that you don't really need. And what else could I say? Yeah, so basically, I just encourage everyone to stay competitive and to give it a shot, because sooner or later you're gonna be learning it regardless. Why not do it earlier on? And as I said, it is still in beta, but a lot of API is still experimental, but a lot of the concepts are still intact. A lot of the concepts are still going to be preserved. It's going to be taking a very long time for them to be deprecated. So it's not like you're going to be relearning a bunch of stuff in a year. All of this stays the same. And all of the newer project, I mean, there is no need to not write in Jetpack Compose. I only see the increase of the projects using it, and as the time goes by, only more and more of those will be focusing on Compose and not XML. So why waste your time, and why delay the inevitable, right? So I think this is a great step towards the future of development, which is going to save us a lot of time, which is going to help us produce much better and much more much better applications with much better designs, much less bugs, and that are much more user-friendly. So as this presentation is coming to its end, any questions?
Thank you, Mike. I have a question. When we started, you said that you basically came to Jetpack Compose as a complete beginner. Could you share what helped you? What resources have you been using to learn how to work with Jetpack?
Well, basically how it went is I did not have much time to do any studies myself beforehand. So it's not like I was using 10 different code labs, some book, 10 different blogs. I was basically thrown into a code base that was already using Jetpack Compose, and it it was not really optimal, which is one of the things that were not going great for me, because I did not understand an insane amount of stuff here. So as I said, it's not like you can just switch to Compose in one day. And I did not realize that, because my initial thought was, oh well, this is just some UI framework, nothing interesting, nothing difficult, I think. So I will quickly understand what's going on and be able to work on it regardless, after all, what's the matter. But in reality, it turned out that, as I mentioned before, all of the fundamentals are shifted. The syntaxes is completely different. The ideas behind creating UI is completely different. And the way you have to think about it is completely different. So it's not like XML is not declarative. It's also declarative, and Jetpack Compose is declarative. So in both cases, you are trying to tell the application how you expect the view to look like, instead of defining the steps needed to update it, to update the UI. But the fundamental things about your approach towards building such UIs, it's nothing the same. You have to stop thinking in a way that you need to update the values yourself, as I initially thought, because this was very hard for me to get over this wall that I'm not the one who has to update the UI here. It gets updated automatically on recompositions whenever mutable states are changed. And I just could not understand it, because I did not see this in code. I did not have anyone explain this to me, and I did not spend time understanding the fundamental concepts at first. And I was really just bashing my head in a wall, in a closed gate. Well, actually, I could just knock, do some research, and understand everything myself. And the fact that the project was not completely optimized for Compose, so that the previous developer came in and started working on it, it was pretty much the same amount of knowledge as I did. So we were basically both beginners trying to understand what was going on. And it made things even worse. So I would highly recommend to be testing the grounds on some very little demo project of your own. You're going to spend very little time on it, but you will get a lot of understanding, especially if you keep in mind the stuff I was talking about today with modifiers, with encapsulating your compositions in such a way that they are reusable, in modularizing them, in preferring to how's it called? It's called composition over inheritance. So you should be able to prefer to not make custom compositions that just encapsulates one default one. No, it's not default. It's standard one provided to you by framework. You should be also trying to stack the functionality that would actually defer it. And yeah, if you do that, I think you're going to be having a much easier time, because the stuff covered, and for example, the stuff with state, I would likely be spending most of the time on state management, because state management is something that is different here, and it introduces a bunch of new concepts that were not used before often, like remember stuff, and these mutable states that can also be delegated. In my examples, I'm using assign operator to remember something, and then I can use it as a mutable state in a composable function. But in reality, you can say by remember. And in that case, if, for example, you had a mutable state that encapsulates Boolean, you would be passing it as an argument as a regular Boolean. Instead, it is a mutable state. Should it be changed, the compositions will be re-triggered. But I think this is more. This is much less intuitive for someone to understand if they did not use it before. So I stick with defining it as a mutable state explicitly for the sake of this presentation, so everyone understands what's going on. Because if you were to just go all in and use every optimization provided by Compose, you can. Your code, you will be able to understand it, but someone that has just started using it, it will be much harder for them. And myself included, I had a very hard time learning it to begin with. But as I said, now that I'm feeling much more comfortable, I just don't want to switch whatsoever.
Okay, thank you so much. We have another question from Daniel. Just 1 second before we get to it. There is also a question related to the previous question in chat. How long did it take you to learn Jetpack? I mean, it's constant learning, I believe, but...
First of all, yes, it's constant learning. Secondly, it depends on the project. Thank you for the question. It depends on the project you are getting into. So if you are already in a group of professionals that know what they're doing, it's going to be very easy. If it's a project that everyone is just testing the ground, trust me, it's not going to be easy to be testing the grounds with them. Well, they've already done some things that are not recommended. Of course, it's easy to do something when you can see an example as a benchmark of what your code should look like. But if you're thrown into that space and asked to figure out yourself what needs to be done, it's not going to be easy. It took me, I think, 2 weeks before I could finally be confident that I actually know what happens here. And it took a lot of my energy because I actually had to do a lot of research beforehand. And as I said, there is not that much stuff on the internet when it comes to more specific questions and more specific issues. And if you know that there is some XML tag you could use in the past and do something in a relatively short period of time, you might ask yourself, well, what is the alternative for the compose? It likely is there, but you will have to do some Googling, do some research first, and you will be doing a lot of research to begin with, because this presentation only covered composables that are here to introduce you to the ideas and the syntaxes, but not all of the combinations of layouts and their compositions that can be achieved. And this is something you're going to have to be doing yourself, because there is way too much stuff to be able to cover. And actually, now that we are talking about some of the projects I've encountered before, there is one thing I wanted to mention but kind of forgot, which is in terms of optimization and some tips and tricks I started using. So in these examples, both of them, I'm using lazy column, as I've stated, and everything works perfectly because it's pretty simple. This is a list of items. However, in the project I was first working at, the model was defined in such a way that you had 3 nested lists. You had a model that is defined as a list of lists of lists, and you have to be able to show all of that data. Now, the problem here is that you cannot nest lazy columns. You cannot. You will be getting an exception stating that you cannot nest views. You cannot nest containers, I think it was called, with infinite heights. And this is a problem, because you might be thinking, well, okay, I will just replace these nested lazy columns with a regular column, and everything will be working fine. And well, yes, indeed, it will display you, it will render the views as you want it. However, once you have a model returns that has an insane amount of nested children, for example, your bottommost inner list has 100 elements, and it's not a lazy column, it's a regular column because it's nested. You will get a freeze because it will try to load and render all of them at once, which is obviously bad. And this is something I was trying to fix, and I came up with an elegant solution, I think, which I will shortly cover. So you're faced with this issue, and what can your proposed solutions be? Well, you could potentially try to implement a lazy loading yourself. So you could try to make it as a pager. So for the nested lists, you only load a set amount of items until you scroll to the very bottom before loading the next ones. Yeah. Well, I mean, it will likely work, though it's overly complex, and you have to be able to face bugs that might be introduced with it, some glitches maybe. And the actual solution that I found that was very simple to implement is to actually stop thinking of a model as a nested list, flatten the hierarchy, and consider 3 nested lists as a one single giant list with spaces between items displayed as a separate item, which is just a spacer for whatever padding needed, and each of the header for the nested list displayed as a separate element. Each of the element of the nested list separate element, and stuff like that. And doing so, I've actually managed to delegate all of the hard work and all of the loading and all of the rendering to the framework, which is exactly what you want to do because it's tested, it's working properly, it has a lot of complex computations done in the background, so you don't even have to care about them. And on your side, it's just basically a couple lines of code, which is something that probably is going to be changed in the future, because not being able to nest lazy columns like this is kind of restricting, I would say. So I don't know, maybe when it comes out of beta, it won't be the case anymore. But as it is in beta right now, this is something you should be aware of, that there will be some issues that you will have to use some thinking to get over, because it turned out great, but it required some how's it called, brain ring. It required some thought process between me and my colleagues.
Okay, so there is a question from Daniel. Daniel, would you like to ask?
Oh yeah, thanks for my time. Thanks for your time, first of all, and thanks for your presentation. I got a bunch of questions, but I would like to just add quickly that a few days ago there was a presentation on Kotlin official channel, YouTube channel, and they announced alpha version, so not even beta, but doesn't matter, where they covered the Compose multi-platform. So now you have the same UI which is running on iOS and Android, same code base. So yeah, it's probably a good idea to start with Compose as soon as possible. Yeah, but my question
okay,
is.
This is good. This is big.
Yeah, that's quite big. It's now on web, iOS, Windows, Mac, and Android, so everywhere. And my question is, you mentioned basically using activities and fragments in different way with Compose. So how would you describe that? Like, do you use now like single activity applications, or where would you use even like different, I don't know, if activities probably are pretty much the same, but fragments and communication between those elements, composables, you know, I know the state hoisting you mentioned, but it's just so different with views. So could you elaborate a little bit on that? Thanks.
Okay, so I think we would have to look at some, you know, very specific example to be able to sort things out there. But generally, first of all, I always tend to use single activity applications whenever I can. Sometimes I'm not able to do so, but this is something I'm always striving for. And by using single activity, you're always getting more benefits than problems. And this is something I always try to do. In a thing about the fragments, there are pretty much no fragments here. There is no such concept as a fragment, because you always have this outer container which is like a parent composable. Sadly, I don't have the screenshot, I think, for this. Oh, 1 second, maybe I do. Yeah, sadly not. But this screenshot is pretty much as close as we would get to main activity. In the main activity, there is this composable called set content. Set content, inside of it, you basically define all of the screens you need, and these screens themselves are basically you could think of them on an abstract level as a fragment. It's just it does not have the same level of communications. Each of the screens, I call them screens, but in reality they're just the same composable functions. It's just they are mentioned in the navigational host here. So nothing differs them in this matter. And when it comes to communication between those, well, I think I will have to look at some concrete examples, because first of all, you could try setting up like a parent-child communication via the mutable state itself. First of all, second of all, you could try doing some magic with view models. I don't think you would want to do interfaces like some child fragment listener as you would do with XML approach. You would probably do some activity defined as a certain fragment listener, and then in the fragment you check whether parent activity is a listener, and then if it is, call a specific method. I don't think you would be doing stuff like that here, but I haven't really encountered much of the scenarios where I would had to do something like really advanced like this. But as I said, no such things as fragment, but there are such things as activity. Always strive for single activity, and you're gonna be golden. Okay. Any other questions?
Thanks.
Is there any other question? Maybe Daniel, could I ask you?
Okay, if there is no, then me again. Sorry. So I stumbled across some site using Figma and a plugin called Relay, which basically converts your drag and drop UI, let's call it, into working compose code. Have you, tried something like this, and do you have any positive or negative experience with it? Tools like Figma.
That sounds really good. That sounds really good. I did not use it, but as I mentioned when talking about separation for XML view tree and your fragment, that it's separated. Obviously, I'm someone who would be down for that 100%. If there is any chance that a designer can define composable code for me, instead of myself doing that, I would personally be really grateful if there was a way to be able to provide me with theming to begin with a bunch of predefined styles for texts and stuff like that. All of the colors needed in order to be able to switch between day and night theme, in order to not define any of this manually myself. If there are some instruments like that,
I mean, it's even more complex than that. It's even more complex than that. You can do buttons, you can do scrolling stuff, and all sorts of things, even parameters, change them, padding, and that kind of stuff. So I was also blown away. It's completely new to me. It's called Figma, and the plugin is, I believe, it's Relay, and it's pretty new, maybe a couple months old. This plugin, which you just set up there and in Android Studio, and it does the job for you. It generates, basically, it builds the project and generates the composable code. So I'm also just curious how it works at this point.
Yeah, that sounds crazy, but I think in reality there might be some underlying little issues. Like, for example, probably. It will be working for you 100%. Oh, not 100%, but well, if it works, obviously it works. But I am pretty certain that if you were to be able to support this code and to be able to add something, scale it, I don't think this is the code that would have the needed amount of modularization, and it would likely not be structured that great. After all, I'm not not a foreigner to AIs, but I was using some AI tools myself extensively, and I can tell that it is 100% of a great help for the developer. But with the amount of complexity you are trying to achieve with it, you're gonna be having worse and worse results, because this thing will likely not be able to handle all of this correctly. Now, I'm not certain if it's powered by AI. It likely should be, because why not? Why define it all manually? But I think that stuff like this is better used for some basic things like theming and stuff like that, and stuff like defining the actual layouts and the way they should be interacting with each other is better left for programmers, for now at least. Maybe this changes in like 5 years or so, but for now I would rather keep it simple when it comes to plugins like that. But this sounds crazy and very interesting regardless, 100%. Thanks for sharing.
Okay, anyone else? Any question to Mike regarding Jetpack? Okay. Maybe, Mike, can I ask you to share in the chat if you have any, like the links to any resources, which, I mean, I know you said there is not many, but if you have any, like useful, is there maybe any group where people can, like share their knowledge or experience or anything which might be useful for people who starting with that?
Well, first of all, it's developersandroid.com, as we always use it. And second of all, your second best friend is Stack Overflow. And really, as I've mentioned the AI already, I would also say that stuff like Bing AI is your amazing friend when it comes to learning new technologies like this, because it actually, most of the time, it knew more stuff than I could. It knew more stuff immediately than I could gather by scrolling the forums for 5 minutes or so. it's always much easier to just specify what exactly you're not understanding properly. And the thing is likely going to give you a correct answer if it's not something overly complex or crazy, because it is not on the same level as some expert developer, obviously. But when you're getting into something, 100% great tool to help you with. It scrolls the web. It keeps you up with relative information. There is really nothing I can tell to not use it. It's very helpful. Used me a lot, or helped me a lot.
Perfect. Thank you so much. Who didn't see it, there is also a link to official course which Daniel was using. So you might be interested also to follow that. We will also include the links in the recording so that people will be able to find it. Last chance. Any more questions? No, it seems not. So then thank you very much, Mike, for great introduction and sharing with us your path of learning how to work with Jetpack Compose. Thank you, everyone, for listening, also in being involved in the discussion and conversation about it. I believe it's great for the common knowledge sharing to do more events like that. And we will be excited to see you again soon by another Smitio event. Thank you so much, Mike.
Thank you so much for this opportunity as well. Thank you all for your time. It was really fun. I was glad to be part of this. Thank you.
Thank you as well. Have a lovely day, everyone, and see you again soon.